And what you're going to see today is not just the product, but the people and the processes behind the product. Who are we really? You know, beyond the ads and the branding and the naming, who the heck are these guys and what have they done?
The professional market is coming to us for their solutions because we really pay attention to the details here and making sure that they can get their job done quicker with higher reliability and certainly with gorgeous innovative products here.
My name is Josh Peterson, and I'm Director of Product Marketing for both mobile workstations and desktop workstations. Whether we're talking about the desktop towers, the all-in-one, the mobile workstations, across the entire product portfolio, we have a very complete product line, and more complete than any of our competitors in the industry. And it's something that we're proud of, and I think it's helped lead to that market leadership position that Jim shared with you. We've seen tremendous growth in the workstation industry through the small form factor. A lot of customers wanting a small package, but workstation class reliability, workstation class performance. And so, you know, one of the things that you'll see on all of our workstations is a commitment to tool-free serviceability, even in our lowest cost workstation. So when my team defines this class of workstation, one of the top criteria is cost. It has to be PC-like prices at the end of the day, because what we want when customers are evaluating, do I buy a commercial desktop PC or do I buy an entry-level workstation, that step up in price has to be really small. Otherwise, you price yourself out for that class of customer. And so it's not uncommon for us to be arguing about nickels and dimes when it comes to, do we want to add that feature or how do we implement that feature? And so we're very cost focused. But what we don't trade off is quality. We don't trade off performance with respect to workstation class architecture. So you're going to get Xeon class processors, professional 3D graphics, ECC memory, ISV certifications, and the ruggedness and reliability that you'll get a sense of as you take the tour. So again, it's the same architecture that you find here. On the Z200 series, you're going to get quad-core processors, 4 DIMM slots, ECC memory, professional 3D graphics, full-height cards in the tower, half-height cards in the small form factor. And if you compare this to our competitor's product, it's more tool-free, it's more expandable. We've got a 400-watt power supply, which gives us a little bit more reach on richer configurations than the competitive system. But on the small form factor, our closest competitor doesn't offer that form factor, so that's something that's worked well for us. But again, PC-like prices, no compromise from a workstation value proposition. Next, I'm going to highlight our Z420. So this is our best-selling workstation. So this is the, when you think about like price performance curves, the Z420 is kind of the knee in the curve. This is where you're going to get the best performance at the lowest price. But it is still a single processor box. It's got a 600-watt power supply, so you can put 2 high-end graphics cards in it, but you're only going to get up to 1 CPU, and the focus here is also on cost. So what we want to do is deliver that kind of the higher-end performance architecture, the server class architecture, but at very low prices. And so we focus on costs here. We argue over nickels and dimes here as well. But this one is going to give you that server class performance. So whereas the Z2 topped out at 4 cores and 4 DIMM slots, we can get up to 8 CPU cores here with a single processor. We have 8 DIMM slots, so you can put large memory configurations in and still have slots to expand over time. You can put 2 3D cards in here. You can see we support up to 4 hard drives. There's 3 hard drive bays here. We can also support a 4th hard drive in the bay because the power supply is big enough to support pretty rich configurations. So again, this is kind of our mainstream workstation. We talk about the customer segments that Jeff talked about. We're talking about like entry-level engineering or media and entertainment. This is kind of actually my product manager for this, he's from Texas, and he calls this the pickup truck of our product line. It can do everything. I think it's because he's from Texas. But next up is our Z620. A couple things to highlight here. As you move from the 400 series to the 600 series, they share the same architecture. But what you get on the 620 is you get 2 processors now. So where you can support 1 8-core CPU there, now we can support 2 8-core CPUs here. We have a lot of customers that buy this with just 1 processor. but the promise of being able to add the second processor is attractive to them, and so you can upgrade it. Or a lot of our customers might have a situation where you have some engineers that need dual processor, some engineers that only need one processor, but they only want one system to own and manage. And so the Z600 series is very versatile, right? It can reach low into single processor configurations, but it can also reach high into those dual processor configurations. It's got a bigger power supply, so you can put a richer graphics configuration in it. You can see from the outside that there's a bit more styling. You can see that the aluminum side panel comes off toollessly, just like I showed you on the Z4. But this one's very rugged. You can see that there's laser etching that we do for the the directions on the inside, and that avoids us from having to do an adhesive label, which helps with the recyclability of our product as well. But when you open up the workstation on the inside, you can see, again, very tool-free. You can see even the power supply here, it becomes tool-free. We have also, we moved to cable-free for hard drives. So the hard drives, as we move into this class, we get away from even cables for the hard drive. So it's a tool-free, cable-free design. So the carrier comes and there's no tools here. You can see we even have isolation grommets here to for high 15,000 RPM drives make a lot of noise. And the other thing that I want you to take away, I'm giving you a list from today, is the focus that we have on acoustics. At the end of the day, what we're doing in Workstations is we're taking server class performance that's made for a back room, and we're making it quiet so you can put it under your desk. And that's a huge challenge for engineering, and we do a better job of it than any of our competitors, really. And this is just a small example, right? The rubber grommets on the hard drive. But if I wanted to upgrade or change out a hard drive, it's really as simple as putting it in the carrier, slapping it in. I don't have to connect cables. I don't have to use tools. And so you can see we've got 3 hard drive bays here. We support up to 4 hard drives if you use an optical bay. I mentioned the fact that a lot of our customers buy this with a single processor. You can also have the ability to later, or at the time of purchase, order a second processor where you actually get the CPU upgrade module. The CPU upgrade module allows you to run a second Xeon E5 series processor, and you have 4 more DIMM slots. So in a single processor you have 8 DIMM slots, and you can add 4 more DIMM slots, so a total of 12 memory slots. So the promise of being able to add the second processor is kind of a future-proof for their investment. Intel has 2 different classes of Xeon E5. The 1600 series only support one processor. You can never add a second one. And we support that on this product as well. But if you get the E5 2600, you can add the 2 processors. And so we support both classes of processor in here, because there are some customers that may never want to add a second processor, but they like the styling, they like the tool-free, maybe they want a richer graphics configuration. And also we have slide kits for racking. A lot of customers like to rack our workstations, and so this has got a very elegant racking solution to it. And so this is by far our most versatile workstation in our product line, which is the Z620, because it can reach low for single processor, but it can also reach into really high configurations. This workstation is actually smaller than our Z420 workstation that has only 1 processor. So the engineering folks have done an amazing job of putting lots of performance in a small box, but yet we're keeping it really quiet. All right, this is our flagship. This is the Z820. It is by far the most expandable, highest performance workstation that we have in our line. We've got 2 processors in here. You'll see it looks very similar to the Z6. It's bigger though, visibly bigger, and that's because you can put a lot more stuff in it. This is a very popular box amongst like oil and gas customers, DreamWorks, the high-end movie studios, people that really no compromise performance. Let me turn this a little better. No compromise performance and expandability for somebody that really has high-end needs. And you'll see as you open it up, this hasn't changed a lot from the Z800 if you're familiar with that, but we worked on keeping this very, very clean. And you might say there's some, why would you do something like this? And I think you'll hear throughout the day some of the design elements that we've. It's not just to make it look pretty. There's actually a function to all these components. But you can see that it's very, very modular, very tool-free. This is something I want to just highlight. This is the cooling module for the Z820. And this, if you can see, there's mini fans here. And one would say, well, why would you have so many fans? Doesn't that make your box loud? And the truth is it actually makes our box quieter, because what we can do is We have many thermal sensors inside here, and we can actually adjust the speed of the fans depending on how hot that spot is. So, and by the way, since it's so close to the hot spot, we don't have to turn the fan very fast to move enough air to cool it. And so we dynamically control the speed of the fans, and that keeps the acoustics down and all the components cool. And throughout the tour, you'll see some of the parts of the lab where we've done the R&D research on how to get that done. There's a tool processor here. This is outfitted with our liquid cooling module, again for customers that want really quiet acoustics. You can see there's 4 hard drive bays here, but we support up to 6 hard drives. If I have a power supply failure or a problem, I want to test it. It's as simple as pulling it out, and I can test it or replace it. That's something that, again, it is bringing cool air. It's not bringing preheated air in to cool it. It's bringing cool air from the front of the chassis. So again, a lot of focus on acoustics, a lot of focus on reliability, and certainly serviceability as our customers want to upgrade or service the products over time. This product has a big enough power supply. It's over 1,000 watts, so it's 1,125 watt power supply. So if you think about that, that's a lot of light bulbs, right? If you think about the performance. And so, putting this under your desk, it's a challenge to keep it quiet. So you see some of the innovations. With this size power supply, though, it supports up to 2 high-end graphics cards. So NVIDIA's highest-end graphics card, 2 high-end processors, lots of hard drives, lots of memory. We actually have already sold several systems with 512 gigabytes of memory for those really nosebleed customers. Not everybody needs it, but you can do that in the Z820. So this is our mobile workstation product line. We do have the broadest portfolio in the industry. It's our travel-friendly mobile workstation. So is it an Ultrabook? No, it's not an Ultrabook, but it is no compromise workstation performance. It's quad-core, professional 3D graphics. It's mil-spec certified, so you can stand on it, you can drop it, you can. It's going to put up to the abuse that customers have in their environment because of the testing and the design that went into it. And when we do a research with our customers, everybody wants thinner, everybody wants lighter, but when you talk to our customers about what they really want and how would they prioritize their purchasing criteria, performance is unanimously always at the top. Our customers are insatiable demand for performance. So the question earlier about the BYOD impact to desktop, I think in the workstation space, our class of customers always, they have this insatiable demand for performance, and as soon as you give them a little bit more performance, they use it. They bring it into the workflow. If you open it up, you can see our style and design is going to be very similar. In the 14-inch, we've got a large touchpad, so as customers eventually move to Windows 8, we'll have gesture-based touchpad that's larger. If you compare that to the competitors, it's quite a bit larger. And again, we did that because we know Windows 8 is coming and there's gestures that people are going to want to take advantage of some of the Windows 8 features. This is our 15-inch. This is our best-selling mobile workstation. It's the mainstream. It's the perfect balance of mobility and performance, right? So as you move up into the 15-inch, you get obviously a bigger screen. You get a 15.6-inch screen. Both of these are 2-spindle designs. And so you can have a hard drive and an optical bay or 2 hard drives rated. We also added a numerical keypad, which if you look at some of our competitor products, they don't have a numerical keypad, and we've gotten lots of feedback from our engineering customers, our media and entertainment customers. They're always entering dimensions or time codes, and so having the numerical keypad is important to them. And again, the larger touchpad. This also comes, I think Jim or Jeff this morning mentioned a dream color option. And so you have various choices of screen, and one of them is a dream color option. So you get full IPS, billion color display, 10-bit, true 10-bit. And so for the movie studio customers that are out on set doing work, actually on set, they can actually do their color critical work on the mobile workstation. Rugged design, but performance and in a mobile platform. Okay, and some people ask about the rugged design. I'll go ahead and I'll stand on this one just so you can get a sense of the ruggedness of the system. Okay, so this is our 15-inch mobile workstation, and not everybody, we don't encourage our customers, don't stand on your workstation, but they are designed for that mil-spec. And part of the mil-spec testing is they get dropped 26 times at 30 inches, covering each face. You can actually, with the flip of a switch, you can take the back door off and you get complete access to the hard drive, the memory, the Wi-Fi cards. And so with a single door, you can get access to the internal components. And so we're really trying to drive consistency across our line, even in the mobiles from a serviceability standpoint. This is a 3-spindle design, meaning I can put 3 hard drives in here in a RAID 5 configuration, up to 32 gigabytes of memory, quad-core performance, and then as you move from the 14 to the 15 to the 17, you're going to get better graphics choices, right? So you get higher end performance graphics. This one actually supports up to Quadro 5000M class graphics, which is actually a step higher than what we can support on the Z1 even. So this is a very, very high performance workstation and very popular among oil and gas and movie studio customers. It's certainly not ultrabook. It's a little bit heavier, but you're not going to sacrifice on ruggedability or ruggedness or reliability or performance. And at the end of the day, that's really what our customers are telling us they want in a workstation. The Z1 again is a workstation class machine, but it's an all-in-one form factor. So what that means is we're not going to compromise on any of those features I talked about. It's a 27-inch IPS display, so it's the same thing as our ZR27 40W just panel. So it's 2560 by 1440, billion colors, IPS, so you get the wide viewing angle. But one of the things that's consistent across all of our workstations is the serviceability. And so, if you talk about all-in-one form factor, that typically is a trade-off, is upgradability and serviceability. And if I want to upgrade the system, it's like opening up a briefcase, and on the inside of my briefcase, I can get to my hard drive. So if I want to change out the hard drive or upgrade the graphics card, I can do that again with no tools and with very little time. And what's interesting is this feature, while it shows well at press events, is why customers, especially in universities, are buying the Z1. So we've seen tremendous success in schools with the Z1, as well as small offices that are doing Adobe or AutoCAD. But schools are really loving the Z1 because students come in and every semester they might have to change their curriculum and rejigger the lab for a different course, so they can reconfigure an all-in-one workstation. They can service things. The students come in with gummed up CDs and they put it in, and they don't have to decommission and send it in for service. They can do it right then and there in a matter of seconds, literally. And so we've had tremendous success with the Z1 in universities and schools. The performance displays represents the best of the best when it comes to visual performance. In addition to visual performance, we do things like, you talk about productivity. The stands are pretty innovative, where there's pretty high, lots of height adjustment. There's a swivel where there's actually a pivot in the stand where you can pivot it. If you want to go into portrait mode, you can go into portrait mode. It tilts, of course, and so there's they call it 8-way comfort adjust. But the stand itself is, I think, very innovative, and our customers really appreciate that. And that's before you even start talking about the specs of the glass itself. We talked about the specs. It's all of our performance displays are IPS panels. What that means, you're going to get really fast response times, really wide viewing angle. And why is that important? A lot of our customers are doing it with multiple displays, and a lot of times multiple big displays. And so you're never looking on axis at all of the displays. So wide viewing angle gives you very, very good visual performance, even when you're kind of looking at it from an angle. And then the last piece is HP Performance Advisor. I already talked about this. Again, it helps customers who aren't software experts tune their application for the best possible performance. Where this really becomes important is as we're inviting the Apple immigrants to come and try Windows. Performance Advisor helps them tune their system so that they may be new to Windows. This helps them tune their system to get the best possible performance, even if they're not familiar with it. So there's a lot of benefits to Performance Advisor for those customers that may be new to Windows even.
Jim always says this is the world's first all-in-one workstation, but you'll notice this really is an all-in-one workstation also. This is the 7-inch all-in-one workstation. That's the 27-inch. And that's why often you'll see that we say it's the world's first 27-inch workstation. Now you know why, right? Because we've had all-in-one workstations back in our history. Somewhere along the way, we lost our way, I guess. We did towers and pizza boxes, but eventually we came back to all-in-ones. This product was used for the Tron movie by Disney to do camera control and titling. Over those years, it's been mentioned a few times, but all of the technologies that go into the workstations for high-performance computing elements were also developed here in Fort Collins. So here in Fort Collins, we had silicon on sapphire processors, and we had Motorola 68K. And then over the years, we did PA RISC processor designs actually here, and then Itanium. So the technology that's in processors we understand very well. We also did chipsets here. I actually led a team within the workstation business that developed chipsets for about 10 years. And then we also did a lot of graphics technology here. So we did graphics chips and graphics boards, custom designed proprietary by HP. So because of that experience we have, we obviously understand what goes into making performance technology, and we also understand what goes into testing and how to deliver the quality. So as those elements have become industry standard, we apply the testing and knowledge we have about the technology in the products that we create today. When new technologies like GPU, for example, come into our market, we're first to move with those. We have those in our products as soon as possible because our customers need that to be competitive as well. And one thing that hasn't been talked about much is long product life. We design our products so that they will last 5 to 10 years. In fact, we'll talk a little bit about that as a design standard when we get into components. But that's our expectation. Customers that make investments in workstations intend to use them for a long time because the workstation itself is a rather large investment. But they also spend money on application software on top of that, and that entire investment is important to them. So we have, with our years of experience, defined very high design standards that we design to. We have built into those standards the ability to margin and drive quality beyond the industry standards, and you'll see a little bit more about that later. Sometimes people say, what's the secret sauce? How have you guys been successful? And there's really two different parts. The first part is that we really understand what we're shooting for as a target in our products. What's the difference between a workstation and other products? So part of that, for example, is the usage model. A lot of the customers that we have will use computers on a 24/7 basis. They're going to use them day in and day out because they might be doing simulations or media and entertainment rendering that takes hours, days, whatever, but they want to run continuously. So in addition to that, they may also use performance levels like I described in that one customer case that are max performance, which is very unusual. So we design, again, for that standard of full performance and also 24/7. Another aspect of our products is the range of configurability and expandability. Josh mentioned the fact that we have some customers that buy half-terabyte systems. We have dozens of folks buying quarter-terabyte systems. So wide range of memory. We have customers that use so many disks, they not only fill up the workstation itself, but they add on a JBOD outside with additional disks. We have customers that want multiple graphics cards because they have 6 displays or more, and they need high performance for all of those. Last, we have enterprise quality components, and so there's some things that you're going to find exceptionally in a workstation you're not going to find in standard commercial PCs, like error correcting memory, like SAS hard drives or SLC SSDs. And the reason for that, of course, is that we have a need for data integrity in some cases beyond what you might want in a standard PC. In the motherboard design area, you're going to see the area in our lab today where we do motherboard bring up, and the focus in that area is actually around electrical signal integrity. So we will look at the signals, we'll adjust parameters in the silicon to optimize the performance of those signals so they have the greatest amount of margin. We did some new PC boards this year for green that are BFR PVC free. That was a new standard we actually drove uniquely. There's a materials analysis lab you're going to see later today in the afternoon. There we can do chemical, mechanical, or even X-ray analysis of parts. We use that to look at components that we're going to be choosing to put into the design in the first place. We may look at the thickness of the gold plating on connectors, the mechanical construction of those. We can look at mechanisms like hard drives and what's going on inside with 3D X-ray. The focus there is really to pick the best components again. We often, if we find things that we don't like, we can work with the suppliers to improve them. So the result of all of this work for us is that we feel very strongly and we have good belief that we're delivering industry-leading quality for the workstation products.
And so what you'll see today are things like where we test radio frequency emissions. We have a 10-meter chamber right here on site. We have our hardware test facility where we do temperature, humidity, altitude. We want to make sure that these systems perform reliably, whether they're operating in the back of a bus or on a truck or in whatever climate, Alaska, the Central America, or humid climates. We'll also show you the material science lab where we actually look at things under X-ray and electron microscopes to really not only determine failure modes, but we're proactive. We basically take systems apart. We order systems from the factory and we take them apart. We look at screws under the X-ray machine, under the electron microscope, and really validate that they are being produced as we originally specified them. So we do that throughout the life of the platform. We'll go into the R&D lab where we're testing prototypes, early prototypes, and we'll go over what kind of testing we do for graphics, for the processors, for the hard drives, all the individual components. What you'll also see is a model shop, and we can prototype through our machine shop here in Fort Collins some of the early versions of our components that we'll go into. That allows our engineers to really take their design, implement it, and then test it, and then iterate on that very quickly. This is our museum, our workstation museum here. Some of the products, it's just a sampling of some of the products we've developed here in Fort Collins, dating back to the late 70s with what we called our desktop calculator, to moving into the 80s with the 9836C and the 9845C had a color display. Another thing we did here, aside from developing our own processors, chipsets, is we had a full-fledged graphics R&D lab here where we used to do all of our graphics cards. Basically leading edge, as we had talked about earlier, competing with silicon graphics. These are some of the 2D graphics cards we had here, and basically, it took cards like this to provide what's today in a little integrated circuit. We're heading to where we do our radio frequency emissions in our 10-meter chamber. Since we're going into an area that actually measures radio frequency emissions, any devices we have that are transmitters, like cell phones, we need to put them in here before we go in.
Welcome to the 10-meter chamber test facility. My name is Brian Annis. I'm an electromagnetic compatibility engineer in the lab. And this is our emissions test facility as opposed to immunity testing, which is done in Building 3, which I think you'll be seeing later today. And there are two types of emissions testing done here. This one here is conducted emissions, and this is, as it suggests, we're measuring the undesired electromagnetic energy that's conducted down the cables from the box. They're not radiated out or transmitted out. They just come down the cables like the power cord and the network cables, the LAN cable. We have special devices here along the wall that we plug the power cords into, and we also plug the LAN cords into, and it picks off the RF energy that we're trying to measure without disturbing the larger building network or the public power supply system. And the other emissions test that we do is radiated emissions right in here. Star Trek door here. This is a special door that's necessary to keep the electromagnetic energy that's out here, out of the chamber, keep our energy inside. Come on in.
This is like Matrix.
Yeah, this is like the Matrix room. Wow.
Feel free to take pictures. We're actually inside a giant steel box. It's welded steel, and it's because we don't want any seams or any gaps in the seams, because at very high frequencies, even a small gap in the seam can let signals in, and we can't allow that. It has to be completely shielded from the outside world. So that's one part of this box. The inside walls, you notice, are treated with cones, these carbon-loaded cones, and behind that are some ferrite tiles. And the ferrite tiles are responsible for absorbing the radio energy that's bouncing around in here. We're trying to prevent it from bouncing around. And that's about the 30 megahertz to 300 megahertz range, maybe up to a gigahertz. Above a gigahertz, It's these carbon-loaded cones that do all the work. And they work all the way up to our upper frequency limit of 40 gigahertz. And here we have a display. That's the display of the spectrum analyzer in our control room. And this is how we troubleshoot the products in real time. And this is very handy for us to get to the root cause of a problem, and diagnose it, and provide feedback to our own R&D lab or to a vendor if it's a graphics card or mass storage. But it's also to protect any device from interfering with any other electronic device, and even the device from interfering with itself, which it can do. If the emissions or the EMC issues are big enough, they can shut down the computer itself. It can't function with all that interference. So yes, the device is acting as an unintentional radiator. It's giving out radiation at all sorts of frequencies that were not intended and not desired. You've probably experienced some of this at home too, where you'll plug in a vacuum cleaner or something, or maybe put a computer next to a TV and it causes problems. That's electromagnetic interference. And these are signal levels generally that are much lower than would be a health risk to humans. So this is much lower than that. So there's no health risk to being in here. It's just the risk to screwing up the measurements from being in here during a measurement. Now later on in the tour, you're going to go to building 3, a true anechoic chamber. It's smaller than this, but it's fully anechoic. And they use that for blasting or bombarding the product with radio energy, very high levels. And you don't want to be in the chamber when they do that. So it's 2 parts. We want to make sure that our products don't emit too much. We also want to make sure that they're sufficiently immune to other devices that may be transmitting nearby.
Welcome everybody, my name is Quick Ready, and we are here outside the Workstation Labs, our R&D Labs Z820, the System Archival Vault. And this, as we step in, and I'll show you in a moment, is where we store all the materials that we will need through the product lifecycle to support our customers from end to end on the products. As you can see in here, we have lots of different optical drives. We have stored fully loaded, highly configured XW workstations. That we have Z workstations in here. We also do everything from memory to hard drives to motherboards, processors, anything we'd ever need to replicate a customer issue through the 3 years of standard warranty and our extended support life is in these sacks. We have an inventory system where we have over 7,900 line items. And in those line items, some of them have multiple components, so we have over 10,000 pieces and parts and systems and everything in these sacks. We have units in here that were introduced in 2006. We have in our XW line, which is the Intel side, we have 4 generations back in the Intel side, and we also have our AMD-based workstations, which have been end of life, no longer can get them. So we have XW9300 and XW9400s in addition to our Z800, and we're starting to add our current products in there, the 820s, the 620s, and the 420s.
And so I'm Dave Randall, and I have the privilege, and I'm honored and humbled to manage a lot of the test facilities that you're seeing today. The 10-meter chamber, the Z-Safe. We're about to take a look at the model shop. You're going to take a look at the hardware test center over in building 3, and so I manage all of that space. I'm the engineering operations manager for the workstation business, and I've been with HP for 30 years. I'm as of a week and a half ago. I'm a mechanical engineer by training, and so I've had the opportunity to work in both production for Hewlett-Packard and in research and development. Spent a good stint in managing processes. I've been in workstation, believe it or not, my entire 30 years here in Fort Collins. And so what we're about to take a look at is, as a mechanical engineer, is what I consider probably one of the coolest places that you could possibly work. This is the model shop. The model shop is a place where the engineers bring their ideas into fruition. They test them, they perfect them, they optimize them. They perfect them both from a performance standpoint, but also from a quality standpoint, and also a manufacturability standpoint. We have 2 master model makers that we employ here. Between them, there's over 50 years of model making and fabrication experience. And so I invite you to come in. This is a machine shop. The tools that we have are traditional hard tooling machines that you might find in the automotive industry, aerospace, hard tooling type things. So behind you, and immediately behind and around you here is our sheet metal equipment. So there's brake presses where we can bend sheet metal, there's shears, there's punches, there's presses where we can insert threaded inserts into it, and so forth. Kind of in the middle section of the shop, we have your traditional tooling, milling machines. We have 3 traditional milling machines. We have a couple of lathes. We have a big milling center back here that you'll see in operation in a few minutes. And then all the ancillary support equipment. The stuff that I'm going to probably talk the most about is our rapid prototyping capabilities. So immediately behind you here is a HP 3D printer. In the back room over here we have a different technology, but it's all rapid prototyping. This is a lay down process. The machine that's in the back room is a build up process. It starts with a vat of liquid plastic and it uses a laser to build the plastic up. We can operate from an engineer's CAD drawing. So the engineers have gone in, they've done their simulations, they've done their engineering, and they come up with a solid model. We can send the solid model to the 3D printer, to the SLA, and within a very, very short time we can have a functional part. When you have a prototype part that comes out of the process, you might want to send it off to the press to take pictures of, to build the promotional materials, and that takes some lead time. You all have your deadlines. But you also might want to send this to the mechanical testing and actually test the physical properties of it. Is it going to be strong enough? Is it going to be too strong? Is it going to cause other problems? And so if you want to send something out for photo ready, you want to use a process that gives you the kind of quality, the visual quality that you would expect to see from a final part. If you want to send something out to just physical testing, you might not care about the aesthetics of it quite so much, but you care a lot about the physical properties. So the plastic that we can do from the lay down process is ABS plastic, which is typically what you find in snap-in details and handles, and so this is what the production part looks like for the carrier for this disk drive, but this is what the prototype looked like. So the engineer was able to work with this early on in the design process to perfect it, to perfect the latching mechanism, perfect the camming mechanism, and so we would want to use plastic that is characteristic of the final part. Whereas a part like this was ginned up, it's part of a server product, it's an I/O plate for a server product, where what they wanted to do is they wanted to build out a system and send it off to build the promotion materials for. So what they cared about was photo ready. And so this is an SLA part, it's plastic. We wouldn't do this with in production, but it's a plastic part. Painted it, we have a laser etcher that you'll see in a few minutes, and we were able to put some very, very fine detail on this, give it to the engineering team, they put together the prototype system and off to the Photoshop and went. You heard about Red Camera this morning. So Red Camera comes to us, they want us to do some customization to the product, and so the engineers started working on this, and they said, okay, well, we can replace these optical drives and our optical bays, and we can use that real estate. And so this is a part that was produced on the SLA. We went to Red, they said this looks good, this is kind of what we had in mind before we had to go to hard tooling and actually produce the sheet metal part. And so, and you look at the two, and unless I told you which one was the production, you wouldn't really be able to tell. Maybe you're designing and working with an airflow baffle. And what you found, the engineers have found, is that because of the geometry, the airflow is turbulent. Well, turbulent air is more noisy than laminar air. And so you might want to take something that exists and then just tweak it slightly. And so this is a 3D scanner that you can take something that exists, scan it, make your tweaks to it, and then go back to the stereolithography or the ABS process and generate the part, test it, and move on. So what we have here is the handle in the CAD system. So this is how it might come from the engineer, and then it is talking to the milling center here. And this machine turns at 12,000 RPM. Obviously, Matt McGee is one of the model makers here. Matt, tell them about this machine.
It's a 30-tool station, vertical milling center, 12,000 RPMs, automatic tool changing, automatic tool setter. So right now it's hogging out a billet of material to create the top side of those handles. Second operation, turn it over, and cut those handles out the rest of the way.
My name is Omar Benya. I'm a mechanical engineer. I'm part of the R&D lab for desktop workstations. So I'll be giving you a tour of our test center. What do we do here? We essentially do EMC testing, electromagnetic compatibility testing. This test facility is ISO 17025 certified. The other thing that we do here is we have HP defined tests, environmental tests. One of the ways we use this facility is as soon as we have functional prototypes, working prototypes, we start putting our designs through its paces. Are there any weaknesses to the designs? If there are any weaknesses, we'll try to understand that and come up with a solution so that in our next development cycle, we will either have addressed or we can again try out that new solution. Right here we have several large environmental chambers. We want to make sure that during the transportation phase we can survive temperature streams. If you can imagine workstation sitting in a container or in a truck in Houston, Texas, in the middle of the day, hot and humid, or it's being trucked overnight in a cold setting like Alaska. And also we want to make sure that once that workstation is deployed, we can survive in those customer environments. For example, we could be installed in a nuclear power plant, an IT server room, TV or video production vehicle. One of the tests is ESD testing, electrostatic discharge test. Why we conduct that test is, if you can imagine, you're in a environment where you're walking on carpet or you're wearing a wool jacket or something, you create a charge and you walk up to one of our systems and you're gonna plug or unplug something, you could actually zap or discharge to our box. So we have an ESD gun that's set to 15 kV volts. We go all the way around the perimeter of the box. We also especially go around the I/O. Another thing that we do is, if you can imagine a weather event like lightning, where it creates a surge through the power line, or if you have a transformer or your grid system that is causing fast transients to the power, we need to be able to survive those sort of events. What we do here is we do a immunity test, constant RF immunity test. So with this antenna, we direct RF energy towards our box, make sure that it's immune to that kind of an event. For example, you can imagine that a workstation could be near a communications tower, radar system, or even things as benign as your cell phones. Cell phones and Wi-Fi systems are intentional radiators. We'll set the box on there, like I said. That whole box is rotatable, so it'll rotate. We'll set it in different orientations to make sure that we essentially can deliver the energy in all angles, in all faces. Another thing that we do in this chamber, and I'm just going to stay quiet for a little bit. This is essentially, we use it as an acoustic chamber. How we use the acoustic chamber is we try out different cooling solutions, different fans, different heat sink solutions to try to see what will give us the best acoustic performance. We also try out different hard drives. If there's a particular hard drive that creates a lot of sound, we try to isolate the hard drives from our chassis so that we can control the vibrational noise that is generated by those rotational hard drives. The floor level of this, noise level in this chamber is about 20 dB. With a new chamber, we're hoping to get down to 14 decibels. What we're showing here is a package vibration test, one of our package vibration tests. For all of our workstations, we design custom foam and boxes. Next, we'll go and do a package drop test. So we do 19 drops. We do all faces. We do corners, edges. Essentially, what we're trying to simulate is somebody accidentally dropping or banging the units during transportation. Carlos is going to demonstrate our track shock test. It's a 30G test. It's quite loud, so if you're sensitive to loud noises, make sure you cover your ears. We want to make sure that there is no damage. For example, graphics cards, they're inserted into a PCI connector. It's not a tight fit, so it's free to move. During vibration, it's been our experience that you can essentially remove the gold plating off of either the connector or on the card. If that happens, it exposes either the copper or nickel layer, which will over time corrode, and that will essentially affect the connectivity between the card and the motherboard. So it could be a long-term reliability issue.
I am Dan Bennett. I am in the Workstations marketing team based here in Fort Collins. Despite the English accent, I've been here 11 years. My accent is apparently an asset. I don't want to lose it. I'm the demo guy. And so my job is to show demos, show the workstations, like for example across the side of the room there, and here. And my job is to communicate the value of HP's products and how wonderful they are. It's not often I get asked to show how wonderful they are at the, in contrast to somebody else's products, but I'll be doing exactly that today. In the media and entertainment content creation space, where does HP stand relative to Apple, with Apple products? Because a lot of people are using Apple for animation content, video editing, coloring, and all this kind of activity. And I want to make it clear that if you're going for the Windows platform, especially from HP, actually gives you some advantages in productivity, and I want to show you what they are. I'm going to start here with all-in-one workstations from HP and from Apple. Of course, we label ours a workstation for good reason, which you've heard about today, like the professional graphics, ECC memory, none of which is inside this box, so we wouldn't really regard it as a workstation, and nor would the people like IDC and Gartner who slice up the market for analysis. I have here Maya 2013 installed on both workstations, and I have a scene here which some of you may recognize if you have ever run the Spec APC benchmarks. Then this is the Toy Store demo. Let me just run it. I'm going to line up my mice on the start buttons and click play. So, in some regards, this is an unfair comparison because on this workstation I have NVIDIA Quadro 4000M graphics, which is a very powerful, if petite, graphics solution, workstation class professional graphics. On the iMac is a Radeon card, which does not at all have the same kind of power. So I'm kind of being disingenuous by saying, I've got a faster graphics card, therefore my demo runs faster. And that's true. So the HP Z1 has finished already. The iMac is still working on the same scene. For those of you familiar with Maya, I am actually showing every frame in the animation rather than dropping frames to play at the same rate. For this particular scene, this animation, the HP is 1.7 times as fast as the iMac. The Z1 workstation can range in price, depending on how you configure it, from parity with the iMac all the way up to a somewhat more pricey workstation. Point is, you can. With the iMac, you can't. There is almost nothing you can upgrade. I mean, we've probably talked about serviceability, and in terms of contrast, it's kind of exemplified by these two products. So the point is, with a Z1 workstation, if you want access to much better productivity, better return on investment from your engineers and animators, then the Z1 lets you reach that point. By spending a little more, you get much better out of it. With the iMac, it's a fixed out-of-the-box experience. There's nothing else that you can change, upgrade, or aspire to. I have another demo, which I'm just going to show essentially the same theme, and it is Premiere Pro CS6. Go. This is a project I put together with 2 streams of HD video and 3 streams of 4K video. And we can see that the HP, not playing totally smoothly, but it's pretty close and very usable. Whereas the iMac, depending on where it is in the movie, just goes into serious clunk mode. Clunk, clunk, clunk. I have HP Z820 with dual 8-core CPUs against a Mac Pro with dual 6-core CPUs. Both of them have Intel hyperthreading turned on. So this system here is giving me 32 cores of CPU power. This one is only giving me 24. Oh dear. And the reason for that is that in the spring this year, HP was time to market with Intel with updating to the new architecture from Intel, the Romley series, the E5-2600 series CPUs. We have access to 8 cores per socket here. Apple apparently didn't find that a valuable proposition, so they didn't go there, right? So we've left them behind. But there's more to it than that. This one, by the way, completed in 22.9 seconds, and this one 38.9. So the Z820 has 1.33 times the number of cores that the Apple has. So even if scaling was exactly according to the number of cores, by rights, this should only go 1.33 times faster than this, okay? And if you compare clock speeds, I've got a 3.1 gigahertz here and 3.06 here, so it's kind of a wash. However, for that rendering, the Z820 was 1.7 times faster. Now why? And the reason is down to the value that Intel has delivered in their new architecture. Intel's new Romley architecture has better memory bandwidth and larger caches inside the package. Whereas the previous generation of CPUs has 3 channels out to memory, the current one has 4. And that gives you better bandwidth, lower latency, and the larger caches means that more of the computation is inside the package. So the combination of new architecture and more cores delivers a much better performance for ray tracing from the Windows HP solution than people are still experiencing with the Apple.